Okay, we can quickly zip through the next example, which is question 2, which is the potassium hydroxide and the hydrochloric acid. The first thing to note again is that we've got a 1-to-1 ratio. Now there's a quick way that we can do it. If it's a 1-to-1 ratio, we can easily just compare the volume and the molarity of both and try to estimate where it's going, where the answer is going to lie. So we've got 10 cubic centimeters of an unknown molarity potassium hydroxide is equivalent to 22.3 times 0.100 moles of the HCl. So we can already see that what we've got is 22.3 cubic centimeters of a 0.1, but we've only got 10 cubic centimeters of our unknown. So we're actually using half as much, actually less than half of the volume. So what we would expect is our molarity to be more than double the molarity of the 0.1. There's an easy way to do it where we've got a 1-to-1 ratio, and we won't sort of focus on calculating the number of moles just yet. We'll just do a simple calculation. So it's 10 times our unknown is equivalent to 22.3 times 0.1. We can simplify that. That's going to be 2.23. So what we've got is 10 times unknown equals 2.23. So we rearrange that. We divide everything by 10. Get rid of that. And that would give us our unknown. So if we go 2.23 divided by 10, we're actually down to 0.223. And that would be the molarity of the potassium hydroxide. If we just double check, we were literally expecting our unknown molarity to be over double the molarity of the HCl because we'd used less than half of the original volume. So basically 10 times our unknown is equal to 22.3 times 0.1. If that's half of that or less than half of that, this figure here has got to be more than double this one. And 0.223 is certainly more than double, just over double the 0.1. So that we know that's our answer for the potassium hydroxide concentration. The question would have asked also, calculate the number of moles of the hydrochloric acid. Well, the number of moles of hydrochloric acid, 22.3 times 0.1, put 22.3 over 1,000, so 23.3 times 0.1 divided by 1,000, so it would be 2.23 times 10 to the minus 3. Because it's a 1-to-1 ratio, that's the number of moles of potassium hydroxide as well.